Assalamualaikum warahmatullahi wabarakatuh. I wish a very good day for Dr. Zaliha binti Muhammad, our lecturer for Numerical Methods, BDA 34103. My name is Muhammad Arif bin Jumali, matric number DD200096. I'm from Group 13, Section 4. And today our group will be presenting about the group project. Our main theme is steam power plant, and for the topic that we will be covering is interpolation. And last but not forget, our group mates Hafiz Aiman bin Anan, Muhammad Aiman Hakim bin Baharum, Alvin Anak Boniface Barong, and Muhammad Arif Nazrin. Okay, let me introduce you to the introduction of the numerical method. The field of mathematics known as numerical analysis is in charge of creating efficient techniques for developing numerical answers to difficult mathematical problems. The majority of mathematical issues in science and engineering are extremely challenging, and sometimes there is no straightforward solution to make difficult mathematical problems easier to solve. Measurement is therefore crucial. A modern tool for scientists and engineers, numeracy has grown in popularity as a result of the tremendous development in computing technology. Meanwhile, numerical methods are methods for approximating mathematical operations because the analytical method is difficult or the procedure cannot be solved analytically. Thus, approximation are needed. Okay, let's take a look the glimpse of history of numerical methods. These are the icons of numerical methods. The first one is Sir Isaac Newton. He introduced Newton divided difference method, and the second one is Joseph Louis Lagrange. He introduced the Lagrange interpolating polynomial that are three order, that is first order, second order, and third order. And the last one is Leonard Euler. He introduced the Euler's method. Okay, for the next real problem, it will be about the military. Before the 12th century, war has been using trebuchet for a very long time, and then after the 12th century, cannon was invented, and then to predict the projectile of the ball cannon that will be landed, they will be calculating the projectile by using the numerical method, so the projectile will be accurate and will hit the target eventually. Alright, let me explain about the focused problem statement. The story begins with, in an oil factory located in Kuala Selangor, a general officer is observing the factory's condition from the inside. As he walks around the boiler section, he notices that the area is unusually hot. Then he quickly called an engineer that was in charge during the time. The engineer was told to do a detailed inspection on the suspected boiler. He then plans to calculate the mass flow rate and thermal efficiency of the boiler. Next, he will compare the value with its standard value of behavior. The superheated, that is A6 table, is also required in order to help solving the problem. By finding the mentioned values, the engineer can determine if the boiler is acting normally or if it has to be repaired.
Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Muhammad Arif Nazir bin Muhammad Kamarun Nizam, and I will present about the objective, scope and methodology for the group project. For the first objective, it is to apply any numerical method to solve real-world mechanical engineering problem. Next, it is to calculate the mass flow rate and thermal efficiency of the boiler. The last objective is to apply appropriate numerical methods using mathematical software for the group assignment. For the first scope, it is to solve the engineering knowledge issue of the nonlinear equation problem using numerical methods with error analysis. Next, it is to explore our independently process lifelong learning in a guided PBL project. Next is the methodology. In this project, we use several types of method to solve the problem. The first one is the first order Lagrange 2 points. So the equation is fx equal to L1x fx1 plus L2x fx2. The second method is the second Lagrange 3 points, which the equation is fx equal to L1x fx1 plus L2x fx2 plus L3x fx3. The third method is the third order Lagrange 4 points. The equation for the second order Lagrange is fx L1x fx1 plus L2x fx2 plus L3x fx3 plus L4x fx4. The fourth method is the Newton divided difference 3 points. So these are the equation. For the equation, we need to find A0, A1 and A2 first before we can solve the equation. So for the last method is the natural cubic spline. In this method, there are several steps in order to solve the problem. The first step is to construct divided difference table, which include HK, DK and BK. Step 2, we must derive simultaneous equation with unknown MK. The third step, we must solve the unknowns. And the last step is to generate formulas for spline cubic polynomials. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman Hakim bin Baharum, and today I will start the presentation with the data gathering. So we got the data gathering from the steam power plant, and we know that the power output is 80 megawatt, and the high pressure turbine at 10 megapascal and lift at 0.8 megapascal, and the rest of steam is reheat at 500 Celsius and it expand in the low pressure turbine to the condenser pressure at 10 kilopascal. So this is a schematic diagram for steam power plant. The next is data gathering from the table A6, which is the 0.8 megapascal at a superheated water table. Okay, we can start the calculation. So first we need to draw the TS diagram. After that, we need to find H1 until the H8. So for the H1, we need find the value enthalpy at the table, and then for the H2, we need to calculate the W pump 1, and we get the H2. After that, we got the H3 from the table, and then we got H4 from the calculate W pump 2, and then we got the H4. After that, we calculate we find the H5 from the table superheated table A6. And then we know that S5 is equal to S6, which is the same. So we need to compare S6 with the SG at 800 kilopascal. So we determine that the S6 larger than SG. So this is a superheated, and we need to find the value H6 at a table A6. but from the table acid, which is the table superheated, there is no following value, which is 6.7585. So we need to do the interpolation. Okay, next we get the data from the superheated water table, and we need to find the value of enthalpy H seed at 6.7585. So we start with the first method, interpolation, which is the first order Lagrange interpolating polynomial. So from this method, we just take a 2 point, and from this case, I take the value of 6.6616 and 6.177. So after that, we substitute into the formula, and then we get the value of the first order is 2812.684,049. Okay, next we move to the second order Lagrange interpolating polynomial, and then from the case we need to identify that's 3 point to determine the value of the H seed, which is the value of enthalpy at the 6.7585, and then from this case we get the 2812.092537.
Hello and good day. My name is Selvin Lucas Barao with metric number CD190328, and today I would like to present about the three methods that we use, which is third order Lagrange interpolating polynomial, Newton's divided difference method until third order, and natural cubic spline interpolation method. So the first method we use is third order Lagrange interpolating polynomial, where the calculation is we use a formula of the third order, and then we insert the value into x and x1. The value is given in the STEAM table, so we insert it into the formula, where the 6.7585 minus 6.177 times with 6.7585 minus 70.0402 and times with 6.7585 minus 7.2345 divided with the 6.6616 minus 6.8177 times 6.6616 minus 7.0402, then times with 6.6616 minus 7.2345, and then multiply with the F1, where the F1 is 2768.3, and then same goes to the sorry, not the F1, I mean the F0, the initial knot, and same goes to the F1 value as well. And then after we calculate all these things together, we will get the answer, the value for 6.7585 for the function 6.77585 equivalent to 2812.147117. Then as for the Newton divided difference, the interpolating, we calculate it by using the table, where the first order we get the value of A1 458.039718. We use 7 decimal places to make it more accurate, to get more accurate value. And then as for the second one is 497.07895517, and then for the third one is 548.1214617. And then after we calculate the first order difference by using the formula, and then we get the second order difference, which is the A2, where we get the 103.113992, and then we get another one value is 122.46355557. And then for the third order, as we get the second order and in the table, we must go with the S value, where we get the third order difference. We get 33.77487607. After we get all this value in this table, and then we insert it into the formula given here. So we get the value, we insert the value, and we find the for the function where the x is 6.7585, we get the answer is 2812.147117. As for the natural cubic spline interpolation method, this is the last method that we use. So for the calculation, for the step 1 is we divide the difference table. As you can see from the difference table, where we find the HK by using the formula of HK plus 1 minus HK value. So here we use the H, where 6.177 minus with 6.6616, we get the value of 0.1561, and for the rest of the value, so where we get the 0.225, and then for the third one is 0.9430, and for the decay value, we use the formula of fx plus 1 minus fx over hk, where the f value for the f1 2,839.8 minus with 2768.3 and divide with the HK value, which is 0.15610, and then we get the answer is 458.036 and then for the D1 we get the answer is 497.0787, and for the D2 we get the answer is 548.1215. After we get all the value of the decay, we look after the BK value. So for the B0 is equal to 6 times DK1, which is 497.078, minus with the DK0 45.0367. So the BK0 value is 234.2340, and then for the B1 is 306.2568. After we calculate for the step 1, we go to the step 2, where the step 2 is derive the simultaneous equation. In here, there is an equation which is HK times MK plus 2 times HK plus 1 times with the MK plus 1 plus H1 times MK plus 2, which is equivalent to BK value. And then from this equation, where the M0 is equal to 0 and M3 is equal to 0 as well. So in order to get the equation, we insert all the value in this table to the equation. So we get the equation is 0.7572 M1 plus 0.2225 M2 equal to 234.2340. Then in order to find the second equation as well, we insert the value in this table as well, and then we get the answer is 0.225 M1 plus 2 times 0.225 plus 0.1643 M2, which equivalent to 30.25680. After we find the through the step 2, we go to the step 3, where we solve the unknown, where the unknown is M1 and M2. So by using substitution method, we calculate into the calculator and we get the M1 value is 218.5255 and for the M2 is 309.0630. Then as for the step 4, we generate the formula for spline cubic polynomial equation by using the formula given here. So before we use the formula, we have to find the A1 and B, not A1, this is AI, and then we look for the B value and C value. So in order to get all this value, we use this table where the A1 value is 23.3179. How I get this value is from the M1 minus with M2 and then divide with 6 times H0, where H0 is 0.1561. After we get we insert the value in this table, we get the answer for the A1. And as for the not A1, the A0. As for the A1, we get the answer is 67.8184. And then as for the A2, we get the negative value, which is negative 265.1081. And next is the B value. The B value, we use this formula where the M0 is divided with 2, which is equal to 0. And then for the M1, 21 at 0.5255 divided with 2, and we get the answer is 109.2628. And same goes to the B2, we get the answer 154.5315, where the 309.0630 is divided by 2. And then we find the value of C value. The C value, we use this table. As you can see here, this value for the F I plus 1 minus Fi over Hi is same as the value with the dk we found in the previous table. So the dk value minus with the 2Hi plus 1 plus H1 times M1 plus 1 divided with 6. So for the C value for C0, we get the value of 452.3544. And then for the C1, we get the value 469.4103. And third one is C2, 528.1045. And then as you can see, the DI value here is equal to the value of the F value, the function, where the 276 for the D0 is 276.8.3, and the D1 is 2839.8, and the D3 is 2950.4. After we finish the calculate for the step 4, we go to the step 5. This step 5, we calculate the interval of function of where x is equal to 6.7585. So by using cubic spline polynomial, we insert the value all in this table into this equation. But in this case, the value of 6.7585 is in between of the 0 and 1, where the 6.6616 and 6.817 is in between this number. So we use the upper value to insert into the formula, where the A1 is 233.3179 times with x minus 6.6616 to the power of 3. And then as for the B value, we use the 0, and the C value we use 452.3544 times x minus 6.6618. And then as for the D value, we also use the D0, where it is 278.3. After we insert all this formula, we insert the x value that we're looking for, which is 6.7585. So we get the answer for the function of where x is 6.7585 is 2812.3454. So the value of function of h at x 6.7585 is equivalent to 2812.3454. That's all from me. Thank you.
Okay, next we move to how to generate the equation. So from the data we get from the steam table, we need to plot at the Excel and we can generate the equation. So after that, we have the equation. We need to substitute the value of the entropy, which is the acids, into the equation, and then we get the actual value of the hash 6. After that, we need to measure the relative error. So we need to find the relative error at the first order until the natural qubit spline. So from this case, we can see that the third order and Newton divided difference have same value and same relative error. So also that's the third order and Newton divided difference has a smaller value compared to others method. So we can choose the value of enthalpy third order and Newton divided difference. So after that, we find the value of hash 7 and hash 8, and then we substitute into the formula to find the value of y. After that, we substitute into the formula q in, q out, and we get the w net. After that, after we get the w net, we can substitute w net into the mass flow rate, and then we can get the value of the mass flow rate. The last but not least, we need to calculate the thermal efficiency of the cycle. So after we get the Q in and Q out, we can substitute into the formula and we get the thermal efficiency for this case. That's all from me.
Assalamualaikum, my name is Aiman bin Adnan. Matric number is TD20041. Today I want to talk about the discussion. This project is the purpose of this study is to apply numerical method to determine the enthalpy of hash 6 from the problem boiler to find the thermal efficiency and mass flow rate. To find the actual value of enthalpy hash 6 for this study, we use the 5 method in interpolation technique, which is first order, second order, third order, Newton divided difference, and natural qubit spline. To make sure the manual calculation for all 5 methods is correct, we use the free mate to check the final answer. And when you want to use the free mate, you need to understand how the free mate. You need to know how to use the coding in free mate to make sure you get your final answer. And when you compare the answer for free mate and your manual calculation, when you get the same answer, it means your manual calculation is correct. After use all the 5 methods in interpolation, the third order Lagrange interpolation and Newton divided difference show us the higher equivalency, the highest equivalency and small error from the actual value. The actual value you can get from graph. For the conclusion, we can say objective of this project have been achieved, and numerical method can be applied to solve the problem of boiler for Kuala Selangor factory. And for use the interpolation method in numerical method, we can find the enthalpy hash 6. When enthalpy hash 6 can be obtained, and you can get the mass flow rate and thermal efficiency to solve the problem boiler in factory Kuala Selangor. And last but not least, For the conclusion, we can say that pre-made make work become easier because you can compare your final answer and pre-made answer same or not. When your final answer same with pre-made answer, we can see that our manual calculation is correct and accurate without any error or false. And for the recommendation, we using the Excel make you get the better graph or correct graph from the data you get from the experiment or from the problem. The graph could be benefit from using Excel to ensure that the graph obtained is accurate among the other recommendation and improvement. Equation for the data value entered in the Excel sheet can be also be created using the software. Using this Excel, it can be inferred that the equation for the data will be obtained without any uncertainty regarding how the calculation is carried out, and the graph sheet will be determined. That's all from me. Thank you.